Mass is 4. Velocity is negative 6. 4 times negative 6 is negative 24. So we've completed step 2. We've calculated the momentum of each object before the collision. Now step number 3 is we want to figure out what is the total momentum of the system. Meaning, what's the total momentum? We're going to add together the red car's momentum with the blue car's momentum. So I'm going to make a little separate box down here. Well, let's do it in green. Total momentum before the collision is going to be 20 plus negative 24 is negative 4. Done with step number 3. Step number 4 is now we want to add up, step number 4 is filling in this box right here. Step number 4 is filling in this box. We want to figure out what is the total momentum of both of these cars after they collide. What's the total momentum of both of these cars after they collide? Well, this is the easiest step because the law of conservation of momentum, it states that the total momentum of a system before a collision will equal the total momentum of a system after the collision. Alright? The total momentum of a system before a collision will equal the total momentum of a system after the collision. What was the total momentum of the system? What was the total momentum of the system before the collision? Well, it was negative 4 kilograms meters per second. It's going to be the same after. Negative 4 kilograms meters per second. Next step. Step number 5. We're going to fill in this box right here. We want to figure out what's the mass. Let me choose a different color for that. What's the mass of both of the objects after they collide? It's the mass of both of those objects after they collide. Well, if the red car was 2 kilograms and the blue car was 4 kilograms, they're just going to be 6 kilograms together. Now we're on the very last step, step number 6. It's this final box. This is asking what's the velocity of both of the cars after the collision. This is what we were trying to figure out, guys. What's the velocity of both of the cars after the collision? That was this big question right here. And the way that we do that is we use our handy dandy formula again. We know that P equals mass times velocity. Do we know the momentum after the collision? We totally do. So I'm going to write it in. Negative 4. Do we know the mass of the cars after the collision? We totally do. Positive 6 kilograms. We don't know the velocity, but we can solve it. What I'm going to do is divide this side by 6 so they can cancel out. Whatever you do to one side, you do to the other. And we get V equals negative 4 over 6. We can reduce that a little bit. V equals negative 2/3. And in physics, you never forget your units. And our units for velocity is meters per second. So here is our answer, folks. Negative 2/3 meters per second. Negative 2/3 meters per second. What does this mean? This means that after they collide, they're going to be moving in the negative direction this way, and negative 2/3 meters per second. The blue car had more momentum. They're going like this. Goodbye, folks. You did very perfect. Very perfect. That's not a thing people say. All right, rock and roll.